is where you incorrectly rejected the null hypothesis. It's a false positive. You're crying wolf and there's no wolf in sight, right? That's the type 1 error. False positive, your pregnancy test comes back positive, but you're not really pregnant, right? That's a type 1 error. Type 2 error is when you're failing to reject a false null hypothesis. So it's a false negative. Your pregnancy test comes back negative, but you're actually pregnant. That would be a type 2 error. Failing to see that the wolf is in sight when the wolf's not actually there. When the wolf is actually there, sorry. There's a wolf in the bushes and you just think it's a squirrel or something. So that's the false negative. Type 1 versus type 2 error, it really depends what your research question is, which one is more important, right? You can imagine that there are pretty dire consequences if you have a type 2 error when it comes to pregnancy tests if you're going out and binge drinking on the weekend, right? You can also be, I mean, both of those are bad. You just don't want errors with a pregnancy test. But you know, crying wolf without the wolf in sight is perhaps a little bit less dire of a situation than thinking that the wolf is just a cat or a squirrel. So it depends on your research question which one is more dire. Okay, so choosing the right test. So look at this handout that you have. You're going to need to ask yourself a few different questions in order to come up with the answer to the test. So you want to know what is the outcome variable, and you have to know that. You have to know that question, or the answer to that question. You want to know if it's continuous, categorical, or if it's like time to event. And really the main ones, time to event, we're not going to cover any of the stats that would assess time to event. So let's just go with like, is it continuous, or is it binary or categorical? Because that's really what determines what test you're going to do. And then what's the unit of observation? So most often it's an individual, right? We do a lot of work though with couples where we'll collect data from both members of the couple. So in those cases, our unit of observation is actually the couple. And that means that we have to use nesting models this is why I got an MPH in biostats, because then we have to use like nesting models where we have to nest the individuals within the couple, and then we have to nest the couple within the multiple days that we collect data. Some of you might be nesting variables if you're collecting multiple measures from an individual. And so then that individual is nested within days. So your unit of observation would still be the person in that case, but you'd be needing to look at the person in the context of all of their other responses, right? If you have repeated measures. And we're not going to cover those stats in today's class. This is like stats 101. So, but if you have questions about what analysis to do, you can ask me. Then you also need to know whether the observations are independent or if they're correlated. So, right, so if they're correlated, then it might be that you collected data from that same person over time, or that two people who are in a relationship with each other reported on their sexual behavior over the past 24 hours. Hopefully correlated. And so they, sometimes not, but, and then once you have that information, then you can look at this, you can look at the table, and you can know then, okay, how am I going to figure out what test to do then? And this is another way to look at this. So if you have that outcome variable as continuous, then your options are these, right? And whether your observations are independent will be like, so say you have an outcome variable that's age, and your observation is independent, then you can choose from a t-test, ANOVA, correlation, or regression, depending on what your research question is. We'll talk about assumptions in a little bit. And then if it's binary, then you become limited, right? Because you don't have that, it's just a totally different type of test that you're going to be doing. And then with time to event, like time to sex or time to death, then these are probably won't be using those very often. We don't see those very much. So yeah, all of the terms that are listed in the middle part here just this part, are test names. So you could just Google that test name and it would tell you how to run that on SPSS. I'm going to show you how to run t-test, ANOVA, chi-square, and correlation, I think. I'm going to show you how to do those in SPSS today. But if you found yourself in a situation where you had these, I have some websites that you can go to try and teach yourself essentially how to run these. And we're going to, as I mentioned, we'll talk about assumptions in a few minutes. So this is even simpler. You've got two categorical variables, chi-square. If you've got a categorical predictor and a continuous outcome, t-test or ANOVA. T-test if there's only two categories, ANOVA if there's more than two. And then if you have continuous predictor variable and your outcome variable is categorical, then you could do a logistic regression. Continuous predictor, categorical outcome. I'm trying to remember what those stand for. But you can do a logistic regression. What's the Q? I can't remember what that one stands for. I can look it up. But and then if you have a continuous predictor and a continuous outcome, regression is typically where you're going to go. Okay? Here's some of those links that are going to be really helpful for you. And actually, yeah, this one's amazing because it has all of the code too. So you can just, if you're using any for SAS data, SPSS, I think it also has it for R. But those are all just different statistical software programs. Okay, so it's clear, right? Totally understand what's going on with statistics. We're going to actually do a quick activity to see how much you understand what's going on with statistics. So I'd like you guys to, you can get into like 2 or 3s, whatever's convenient for you. And we're going to answer a few questions and then talk about each of those questions with the rest of the group, the answers that you come up with. You're going to probably need to have your textbook or a computer or something nearby to be able to look up some of the answers to some of these, but you'll be able to work together and then we'll come back as a group. Okay? So just pair off. We'll just use your 3s. Okay, so within your groups, you are going to figure out the answers to these 4 questions by working together. And I think in particular, the second one will probably require you to look up some things, maybe. The first one, I hope you'd be able to answer just right off the bat. I hope for the third as well, maybe even the fourth, but maybe my hopes are set too high. So you guys can talk with each other and figure out what you think the answers are to each of these 4 questions, and then we'll come back and talk about the answers to all of them.
Correlation plus data. There's a connection. There's a relationship. Yep. But not necessarily
I can't remember that. So once you square your R value.
So a person is just your R squared.
Yeah, for 2, yeah. That's when she said we should go ahead and make the differences among those.
Oh, it's the square of the residuals of each.
Because you did this.
Here's the off. I was just trying to know for outline.
R squared are fitted into the circle. So that line, how far away they are in regards to where they're from.
Very
Yeah. So 38% versus 87%.
Important to know this because
Do you know if Kyle's coming?
What's
that?
the higher the altitude, the closer to one.
That's how whether it's regular like this one's gonna be yeah, but then right R squared says like
Electrical regression affairs. So you get a lot
within reason, you can suggest that if X is Y.
generally within your data parameter.
Okay. Yeah. Which I measure
But you're still under your
bright light. Very hard. I feel like it's a little bit better for passing.
So it's not really hard. I looked it up on my phone. Nicholasville Road, an hour into this train coming down. What are the 3x?
How's it different from the first one? So I think the comparison product moment coefficient is just the measure, whereas the partial correlation describes strength of air.
Why the significant correlation not partial?
Because you don't.
Controls other things. I don't know what those are. I'll look up a partial correlation coefficient and some partial. It measures the degree of association between two random variables with the effect of a set of controlling random variables. Correlation coefficient, partial correlation. So you would take into account other random variables.
This
To
was
try
random
to,
variables.
yeah.
Besides the two.
Yeah, so you would take into account like if BMI, I'm taking exertion measures as well, or modifier velocity.
I'm sorry, what?
No, it's
I can do it.
So it's another description of the strength of that linear.
okay. So mine would be a summary. Taking out the effects of
How's it going? All four? Yeah, sure.
semi-partial,
Okay.
you take it.
So what did Google tell you about what can a correlation tell us about the data? What does it tell us?
Relationship?
If there's a positive or negative relationship between variables, between how many?
2.
2, yeah. So, and what type of variables do those have to be?
Continuous.
Yes, continuous. So it tells you, correlation can tell us that there's a relationship between 2 continuous variables, and it can also tell us the strength of that relationship. And that provides us with an R value that's either, what does it range from? Does anyone know? -1 to +1, yeah. So if it's 0, what's that mean? Nothing. Stupid research question. Probably not, I'm just joking. It's good to know that things aren't related sometimes.